Is it me? Or is it hot in here? As my old professor used to say, if you can't take the heat, get out of my lab. I'm André Isaacs, and this is Heat Capacity and Specific Heat. Different substances can absorb and give off heat to differing degrees. Let's demonstrate this qualitatively using different metals. We'll then do an experiment and the relevant calculation to determine the specific heat of a metal. These metals all have the same mass. I have heated them to the same temperature. I'm going to place them on this wax sheet and allow them to melt downwards. What we can see now is the difference in the amount of wax that melted due to the difference in the specific heats of the metals, even though they all had the same starting temperature. Since aluminum went the furthest, it gave off the most heat and melted the most wax. That means aluminum has the highest specific heat. Lead melted the least wax, so it gave off the least heat and has the lowest specific heat. The equation relating these quantities is specific heat or specific heat capacity equals heat divided by mass times temperature change. Let's now do another simple experiment to try and determine the specific heats of the metals that melted the wax. I have heated 50 grams of aluminum by putting it in a beaker of boiling water and allowing it to reach the temperature of the water 100 degrees Celsius. I'm now going to quickly transfer the aluminum into a high-tech calorimeter styrofoam cup containing 100 grams of water at 25 degrees Celsius. The temperature is monitored throughout this process. It reaches a maximum temperature of 31.8 degrees Celsius and then starts to cool. In short, the temperature through time rises, peaks, and then drops off, just as we would expect it. Now, let's use our data to determine the specific heat of aluminum. The aluminum gave off heat, which was absorbed by the water. Rearranging the specific heat equation lets me determine the heat absorbed by the water, which equals the mass times the specific heat times the temperature change of the water. So the heat of the water is equal to 2,840 joules. If no heat escapes, then the heat of aluminum and the heat of water are equal in magnitude but opposite in sign. Therefore, the heat of aluminum is equal to negative 2,840 joules. We can then use that value to calculate the specific heat of aluminum, which is 0.83 joules per gram degree Celsius. Since some heat inevitably escapes during this process, our experimental value is a little bit lower than the known specific heat, which is 0.9 joules per gram degree Celsius. We could repeat this with the other metals to determine their specific heats. So that tells us a lot. It allows us to understand which metal to use in different situations. Everything from aircraft and rocket parts, and even something like selecting the best base for your frying pan. So, if you can't stand the heat, let's spend some more time in the kitchen. And there you have it.